Welcome everybody. In this video I'm going to explain you the American Statistician Association statement about p-values. ASA is the world's largest community of statisticians. It was founded 180 years ago, but this is the first statement. Why do they make a statement? The last decade, the statistical community has been deeply concerned about the replication of science conclusions, especially how scientists use p-value. That's why they made a statement with 6 principles. What is p-value? Scientists collect data to support their evidences. They use this data that they already have to make inferences from data that they don't have. In practice, they calculate a probability called p-value. Let me explain you p-value with an example. Suppose you have an app and you make an experiment with a new user interface. Will the new user interface have an effect on the sign-up time? To figure it out, we need to set the null hypothesis. Should you reject or not the null hypothesis? Let's assume that the null hypothesis is true. Let's try to figure out the probability that we have something as extreme as our sample. Let's assume our standard deviation of our sample distribution is 0.05. To calculate how many standard deviation away from this mean is 1.05 minutes, we need the z-score. Our sample is away 3 standard deviation below and above the mean. And the question is, what is the probability of getting a result as extreme as our sample? Is the area under the curve, which is 0.3%, our p-value. Let's check every principle. The first one says, in other words, the smaller the p-value, the greater the incompatibility between the data and the statistical model. A common misinterpretation of a p-value is that it can tell you the probability that the null hypothesis is true. The second principle clarifies that. In many fields, you can find conclusions based in a specific threshold for a p-value. The most common is 0.05. However, the third principle clarifies that. Some statistical users manipulate data to get significant p-values, best known as p-hacking. The fourth statement tries to enforce correct statistical practices.